Hello everyone, welcome to Classroom TV. How are you today? I hope you are doing well. So coming to our class, to start with our the class and session, let us discuss some of the changes taking place in nature. As we know, chemistry is study of matter and its changes taking place around the nature. In your earlier classes, you have discussed about chemical changes and physical changes. And you know, physical changes are those changes which takes place in environment where with certain changes which are up to some extent. Means the changes whichever occur physically can brought back to their original substance. But whereas chemical changes are those changes once the change takes place, it's permanent and we can't able to get the original product so far. So now today's class we are going to discuss about the chemical changes taking place in the surroundings or in the nature, and those chemical changes are said to be a sort of chemical reactions, wherein those chemical reactions we analyze it and we try to come to a conclusion. So let us start with a discussion. So you can see here there are different forms of chemical changes taking place in the nature. So you can see the first one, you can see a metal gets rusted. You know, metals reacts with air, okay, the moisture present in the air, and when metals are left openly or when they are kept open to the air or moisture, you see that the metal starts getting rusted up. Can you see the brownish layer is getting deposited on it? So what is this brownish layer? Yes, the brownish layer whatever so has got deposited on it is nothing but it's giving us an indication that it has undergone a chemical change. Means the metal has reacted with air and got corroded up. You know already the process of metal getting when metals are exposed to air or moisture, they get rusted up, and the process wherein metals gets rusted up due to air or moisture is said to be corrosion. So once if any of the metals when they gets rusted up, you know already that it's a permanent in change, isn't it? Can we again get back the rusted metal into the pure form? You can't get it. Once the metals got rusted up, definitely you know it's a permanent change, and these kind of permanent changes wherein we can't bring back the original substance once it's reacted or once it has undergone a chemical change. So those kind of substances are said to be a form of chemical change here. In the same way, you can even see a candle burning. So once if a candle starts burning, you will see that overall the candle starts melting into wax. So once if the wax gets melted, can we get the wax again into its original form? Yeah, we can't get the once the wax which got melted up into its original form again. So in such cases also we say that it's also a form of chemical change. Yes. Then when you come to the next, even not only with only the substances like which are only getting rusted up when exposed to air or when they have been burned, even you can see the ripening of fruits and flowers also. So you can see here bananas turning brown once the fruits or flowers gets ripened, they are also of permanent in nature. Means even those ripening of flowers or fruits are also considered to be a form of chemical change. So once a fruit or a flower has ripened, you will see that no more they are being got back to the same process from where they got germinated. So even ripening of fruits and flowers are also considered to be a form of chemical change. Yes. And Even you can see fire extinguisher. So you can see here a person trying to stop the fire by using a fire extinguisher in the form of a foam. So the substances which catches fire, or generally which has gone across the flammable substances, they easily get catches fire. In such cases, in order to stop the fire, we apply we use different types of fire extinguishers in the form of foam. So wherein that foaming is nothing but it's also a permanent process where we try to stop the fire by undergoing the chemical change. So these are some of the sort of examples which we come across in our daily life in one or the other form, trying to show that there are some sort of changes taking place in the environment and the nature, and those sort of changes which takes place in the environment and nature are grouped together as chemical changes. So now there is a question like, is it really there is a need to go to learn the chemical changes, or can we avoid them? Isn't it? So as I said, like all the chemical changes whichever are taking place in the nature cannot be avoided. They are like like it's a part of life, or it's a part of everyday life applications, where in one or the other form those chemical changes takes place. So in the next slide you will see like not only the ripening of fruits, or only ripening of flowers, or only metal getting rusted up, even you will see the other activities which you do in your daily life are also being classified as one of the chemical changes. So you can see here, when once the food is started cooking, when the food is cooked, can you bring again the cooked food into form of an uncooked form? Yeah, we can't get it. Once if the rice is steamed, can we get the rice particles which are steamed again to its original form? We can't do so. So there are many sort of such changes which are taking place in our daily life, which we doesn't see, means we are not aware of it, or we doesn't see them, or we try to like say just it like an we go on ignore it. But those what are the changes which are taking place, they are of permanent in nature, and those changes which are permanent in nature has undergone the changes, and those changes are of doesn't retain their properties. You will see that overall the original substances has undergone the change in such case. So you can see here cooking is also a type of a chemical change. So once the food is cooked, even that also you have taken in the form of a chemical change. Then even you can see combustion, any of the materials or substances burnt in presence of air, or it's reacting in the oxygen present in air, also a form of a chemical change, isn't it? When you are burning a pieces of paper, so even a pieces of paper when have been burned in presence of air or oxygen present in the surroundings, it is also of permanent change. So it's also a chemical change. Then even you can see digestion process, isn't it? The food which we take in need to be digested to convert into form of energy. So once the food which we take in gets converted to give us energy in the form of burning the calories. So even this is also a form of chemical change. So there are some a maximum of instances or maximum the situations where we come across different types of matter interacting in the surroundings undergoing chemical change. So those chemical changes whatever are taking place in the environment or in surroundings are grouped as chemical reactions. Means in our science or in our chemistry, when these sort of chemical changes whichever are taking place in nature are termed as chemical reactions. They are termed as chemical reactions. So let us start our session. What are these chemical reactions and how these chemical reactions are represented in the form of chemical equation. Actually our chapter name is chemical equation. So how these chemical equations are represented are obtained, means the chemical equations are obtained from a chemical reaction. Then what is a chemical reaction? A chemical reaction is a reaction wherein some of the substances are undergoing a chemical change to form a new substances. So, whichever the substances undergoing a chemical change to form new substances, those new substances are represented in the form of a chemical equation. So, here you can see like in our previous slides we have discussed the various chemical changes. Those various chemical changes we try to refer them to be as a form of chemical reactions. So, what are the chemical changes which we come across? So, you can see different changes which takes place in our daily life. The process of digestion, yes, then a burning of crackers, yes, you like burning crackers, but once you know crackers which are burnt, can we get back again those crackers which are burnt? Yeah, you can't get it. So, even those crackers which are burnt are also a form of a chemical change. That is the reason you insist your parents to buy more and more crackers, because once a set of crackers are burnt, then you feel like to burn more. So, that is the reason you get in excess of quantity, you get as a spare in quantities and you start burning them. So, once the process whichever are undergoing a chemical change are of permanent in nature and wherein the original substance retains it. Then even along with that you can able to see like the process of respiration, the air which we take in and give out the carbon dioxide gas. This is the everyday respiration process is must for us, wherein we take the air and give out the carbon dioxide gas. Then powdered lime added to water, powdered lime added to water. This is actually you might be knowing, it is nothing but your whitewashing of walls. Generally when we whitewash the walls, we take powdered lime. Powdered lime is nothing but actually it is calcium oxide. Calcium oxide is called as quicklime, or we usually say it as only lime. So, that powdered lime is being added to water, and that then once it is added to water, it gets converts into calcium hydroxide solution, and that particular calcium hydroxide solution we apply to the walls, which give us the fine white finished colored substances formed on the wall. It shines also, like that shiny white colored substance we say actually finishing of walls means when you do the finishing, the final coating which you are going to apply to the walls seem to be very whitish and very smooth and soft. So, in such cases also we say once whatever the powdered lime is when it's mixed with water gives you the calcium hydroxide solution, and that calcium hydroxide solution so formed applied on walls turns to be whitish. So, even it is also a chemical change. Then even ripening of the mango, not only ripening of mango, whichever fruits you take, once ripened, again they are not being back to its original form. So, these are apart from those the examples which we seen, along with it even these are also a part of chemical changes. Yes. And exposing iron nails to moisture it leads to rusting up, and the rusting of the iron, or not only iron, all the rusting up of metal leads to corrosion. So, even a corrosion is also a chemical change. Yes. Then how to confirm, like already by by physical appearance we are confirming it, and we have been saying it that the particular substance has undergone a chemical change, but still we want to confirm that how does that chemical reaction has taken place. Means that particular chemical change whatever has been taken place, I have been saying it to as a form of chemical reaction according to our chemistry. What are the chemical changes taking place in the nature are termed to be as a chemical reaction, and those chemical reactions how we need to conclude or how we need to estimate that it is a chemical reaction only. So, once if a chemical reaction takes place, then what are the conclusion or observations are seen from those? So that we are going to see here. So here we go with two general activities here to confirm that it's a chemical reaction has taken place. So here you can see, let us perform an activity. So you can see here we have taken a 100 ml beaker. When 100 ml beaker you have taken water. 100 ml beaker of water you have 100 ml of water you have taken in a beaker, and you have dissolved sodium sulfate. You have dissolved sodium sulfate. I think you know the formula already. It's Na2SO4. So once you have dissolved sodium sulfate, and in another quantity you are going to take another beaker in which you are going to add barium chloride. Yes, you are going to take 200 ml beakers filled with water. In 100 ml of beaker, 100 ml of water you are going to take sodium sulfate. In another 100 ml of beaker you are going to take barium chloride. So both the solutions, like one solution contains barium chloride and one solution contains sodium sulfate, So now here both the solutions, you can see here barium chloride and sodium sulfate. Now you can see they are taken in different beakers. So you can see here like it is a beaker or a test tube, whatever it's so. So the two different solutions which you have prepared, or wherein you have added sodium sulfate and barium chloride in different beakers and you have prepared those solutions. Once these two solutions are mixed together, then you will see that there is a change in the substance. Means before you have added, you can see here the overall the beaker is being signed to be seen colorless. There is no color. Both the solutions, barium chloride solution and even sodium sulfate solution, are colorless. So when both the solutions, when sodium chloride and when sodium sulfate and barium chloride are added, when both of these solutions are added, you will see a white precipitate formed, or a white colored solution. Means overall the colorless solution got turned into white colored solution, and that white colored solution, whatever is being formed, is giving us an confirmation that sodium sulfate and barium chloride has undergone a reaction and formed a new substance. Yes. So in this way we are confirming that how a chemical reaction has taken place, or how a chemical change, means how a new compound has been, a new product is formed which is retaining the original substance. Yes. Then that's one activity. Coming to the one more activity for demonstration purpose to confirm that it's a chemical reaction. So here you can see formation of hydrogen gas by the action of dilute HCl on zinc and testing of hydrogen gas. Now in this case we are going to take metal. We have metal is zinc. So zinc granules are reacting with acids, means metals are reacting with acids. So when metals are reacting with acids, it gives you the respective salt and hydrogen gas. So we need to confirm when the reaction has taken place between an acid and a metal, there was an hydrogen gas evolution, and that hydrogen gas need to be tested. Yes. So you have to take some of these zinc granules. You can see the experimental setup here. In an experimental setup wherein we have taken a conical flask. You know the lab equipments, generally whenever we carry out any of the reactions, we either use beaker, we use test tubes or conical flask, and even we have standardized solutions, round bottom flask. So all the equipments you know already. In one we have taken a conical flask. In a conical flask you have added zinc granule, you have taken some amount of zinc granules, and those zinc granules are dissolved with HCl, and those zinc granules are dissolved with HCl. So once zinc and HCl reacts, once the zinc granules and HCl hydrochloric acid solution reacts together, it forms a respective salt. Along with the respective salt, you are able to see hydrogen gas liberating, isn't it? So, here you are able to see when zinc granules which you have taken in a conical flask, when you are reacting HCl, you are able to see the respective salt formed, so called sodium zinc chloride, and hydrogen gas is liberated. Now, we need to confirm that it's a hydrogen gas only, means we need to prove that there is a chemical reaction has taken place between a metal and an acid. Means when zinc is reacting with hydrochloric acid, when metal is reacting with an acid, there is some gas liberated. Now, we need to confirm that particular gas whichever has been liberated, released in the reaction is hydrogen only. So, what you are going to do here? You are going to take a burning stick, okay, burning matchstick or a splinter. You just take a matchstick and burn it. You will see that once you can see when the hydrogen gas started liberating or coming out of the conical flask, you take the the burning matchstick near to the liberated area, isn't it? You know very well, as the gas formation takes place, gas starts coming out. So, when the gas starts coming out, the fumes whichever comes out, you try to take the matchstick which you have burned near to the liberated area. You see that the flame burns more vigorously with pop sound. It gives you a pop sound when you will see that the flame burns more vigorously, more brightly than the usual flame. So, in this way, how you are being confirming that's an hydrogen gas? Because you are able to see, you are able to hear a sound, the pop sound whichever you are getting, that pop sound, whatever is being heard or here in the reaction is giving us the confirmation that it's a hydrogen gas only. Means when the metals reacts with acids, means the reaction between an acid and a metal gives you hydrogen gas, means hydrogen gas is released in the reaction. So, by this activity also we are coming to a conclusion that there is a chemical reaction taking place. A chemical reaction has taken place. Yes. So, what are the conclusions and what all the observations we have seen in the activity? Let us discuss again. So, observe the changes in the conical flask. What changes you notice? We notice that when zinc granules reacts with dilute HCl, gives you a respective salt and hydrogen gas is released. Along with hydrogen gas released, then now keep a burning matchstick near the mouth of the conical flask. Then what happens to the burning matchstick? So, burning matchstick burns more vigorously than the usual flame with pop sound. So, that pop sound is giving us the confirmation that it's a hydrogen gas only. Yes. Then even in the other way, how to confirm that's a chemical reaction? Means what are the possibilities can happen when a chemical reaction takes place. So, along with the hydrogen gas liberation, even you touch the sides of the conical flask, you will feel hotter. Means it's said that like when you touch the bottom of the conical flask with your finger, what do you notice? When you are touching the contents, means overall when reaction has taken place, you touch the contents, overall the contents with your hand or finger. You will feel hotter, isn't it? Just from outside you touch with your hand, touch with your fingers. The contents has got reacted and your overall you will see that all the contents got heated up and you will feel warmness to your hand. So, that gives an indication that when the chemical reaction takes place, even there is a change in temperature also. That is the reason. Is there any change in temperature? Yes, there is a change in temperature. Before what you say, like when you have taken only the zinc granules and before zinc granules were reacted with HCl, you touch the flask and see. In such case, you will see that the flask is very normal, and you are able to you are not unable to feel any warmness or any hotness. But once the when once the HCl was added, and when zinc granules reacted and liberated the hydrogen gas, then you will see the overall the contents present in the flask has got heated up, become warmer, and which when you touch it, it feels hotness or warmness to your hand. So, even though change in temperature is also an indication that there is a chemical reaction taken place. Yes. So, come to a conclusion. So, what all the conclusion? We come into the final conclusion that the particular substances whichever we have taken has undergone a chemical change, that is a chemical reaction. And how we say that it is a chemical reaction only, means on what basis you can confirm it that it is a chemical reaction only. Yes. So, see here the first foremost important the thing which we get, the original substance loses their characteristics properties. We have been going on saying that the overall the zinc granules reacting with zinc hydrochloric acid has retained their original property and got converted into a respective salt there. So, the original substances lose their characteristics properties, and hence they may be products with different physical states and colors. So, even colors, the change in colors also will also give us the confirmation that there is a chemical change, it has undergone a chemical reaction. In our first activity we have seen, when sodium sulphate and barium chloride reacted together, the overall the colorless solution got turned into a white precipitate, isn't it, a white color. So, the colorless solution has changed into a white color. So, the change in color also gives us the confirmation that it has undergone a chemical reaction. Yes. Then even the chemical changes may be exothermic or endothermic. So, we are going to discuss about it. Exothermic reactions are those wherein the reactions where heat is liberated, heat is given out. So, in the second activity, when zinc granules were reacted with HCl, dilute hydrochloric acid solution, you have seen the overall the contents which has got reacted and made the flask make the conical flask to be very warmer and heated up. So, in such cases also that the heat is been given out, it has been liberated, and even heat can also be utilized also in some of the reactions, and those kind of reactions are said to be endothermic reactions. Exothermic reactions and endothermic reactions. Then not only that, even they may form an insoluble substance known as precipitate. They may even form an insoluble substance known as precipitate. So, in our first activity, we have seen when both of the solutions, when sodium sulphate and barium chloride reacted together, there was a white colored solution formed. That particular white colored solution formed is insoluble in water, means it does not get dissolved in water. Those kind of substances which are insoluble in water, does not dissolve in water, are termed to be as precipitate. Yes. Then gas may be evolved. In our daily life, we observe variety of changes taking place around us. So, even gases may be evolved. In our second activity, we have seen which gas was evolved? Hydrogen gas. So, not only a hydrogen gas, it can be a carbon dioxide gas, it can be a nitrogen, or any of the gases are expected to be released or formed or liberated in a particular chemical reaction when the substances are undergoing a chemical change. Yes. So, in that way we confirmed that sort of chemical reactions. So, whatever the formed chemical reactions or whatever the substances has undergone a chemical reaction, those substances which have undergone a chemical reaction need to be framed in a form of a equation, and whatever the chemical reaction has taken place, that order or the form of writing or framing that chemical reaction in a form of an equation is said to be a chemical equation. So, actually we have started your class with the different types of chemical changes observed in our nature, then with the sort of chemical reactions, and those sort of chemical reactions are need to be framed, means we need to show in so and so it has reacted, means when we took zinc granules, the zinc granules are reacting with HCl to give respective salt and hydrogen gas. So, we need to frame that reaction in form of a sentence or in a form of a statement. So, those type of sentences and the statements whichever has undergone a chemical reaction or as a chemical reaction has taken place, those we need to write in a form of a chemical equation. So, let us start with an example here to come to a give you a clarity. Like you can see the other compound, like one more example where calcium oxide reacts with water, a new substance is formed which is unlike to either calcium oxide or water. So, in this you can see the description of a chemical reactions in a sentence is quite long, isn't it? It's so long, no? It's very long to pronounce it, isn't it? Where a calcium oxide reacts with water to form calcium oxide, or which is different from the water, and so on, so respective products. So, when you have been pronouncing the equation, the reaction which has undergone a change, it's quite long. So, you can't keep on going on saying calcium oxide is reacting with water to form calcium hydroxide and so respective products. So, you can't keep on going on saying the same chemical reaction which has undergone a change to give you a so and so products form. So, we need to come to a shorter a method which we need to follow it, so that we can always avoid the the prolonged way of saying or stating the chemical reaction. So, in such cases it can be written in the shorter form as a word equation. The overall reaction which is quite long, you can see calcium oxide reacting with water forms a new substance. So, instead of going with the prolonged long sentences which is quite long, you can write the same reaction in a shorter form as a word equation, and that particular reaction which you are writing in a shorter form as a word equation is called as a chemical equation. Yes. So, here the word equation of above reaction is, you can see what is the word equation? Calcium oxide, can you see? Calcium oxide reacts with water, means reacts with water is being written in a shorter form with a plus sign. Okay, reacts with, we have replaced the reacts with plus here. With water to form a new substance. So, how to know a new substance is formed? Here arrow will give us the confirmation that this calcium oxide and water has undergone a chemical change where both calcium oxide and water are reacting together to form a new substance. So, how to write a new substance formed? You have a confusion now, like how to, the new substances are formed, no doubt. So, those new substances whichever are formed are being separated by an arrow, means arrow will give us the confirmation that the new substance whichever so formed in a chemical reaction are written this side. So, the what is the new compound substance formed here? It's calcium hydroxide. So, when calcium oxide and water are reacting together to give you a new substance which has been differentiated or separated by an arrow, will give you the original substance formed in that chemical reaction. So, the prolonged form of sentence is written in the form which is written in a shorter form of a reaction which is a word equation. That particular word equation is itself, we are saying it as a chemical equation here. Yes. Next, you might be seeing here, like generally there are two sentence written as reactants and products. So what are these reactants and products here? What are the reactants and products which are being seen here? Yes. So what are those reactants and products which you are seeing here? So you will see here, whenever whichever substances are undergoing a chemical change in a chemical reaction are called reactants, and the new substances which are formed are said to be as products. So in this last slide you can see here, whichever substances are undergoing the change, are undergoing a chemical change, are written to be are said to be as reactants, and once the original substances whichever are so formed after reacting are said to be as products. So in such cases it's very prolonged for us to go on say, or what you say, like go on write in the form of sentences. So that same form of long what you say, the sentences whichever have undergone a reaction is written in a form of a equation, and that particular equation is said to be a chemical equation which are represented on both the sides. So how to know to represent the what you say, the substances which are undergone the reaction to be as reactants, and how to know the new substance form are to be written on this side. So in our next slide we are going to see how these are represented. How these are represented. So you can see here the substances which undergone a chemical change in the reaction are called reactants. So in a previous slide you can see these are the substances which has undergone a chemical change. These were the two substances which are reacting. Calcium oxide and water are reacting together, undergoing a chemical change to form a new product. So the reactants which are undergoing a chemical change to form a product are said to be as reactants. So here you can see, and the new substance whichever are formed are called as products. So here generally you know the representation actually we give like reactants gives products. So the reactants whichever are so undergoing a chemical change, those are called as reactants. And once the substances which has undergone a chemical change to form a new substance are called as products. Yes. Then you can see a chemical reaction written in the form of word equation. A chemical reaction written in the form of word equation shows the change of reactants to products by an arrow placed between them. So you can see here this arrow is giving us the confirmation where we are differentiating the reactants from products. Means when the reaction is taking place, now when zinc granules were reacting with HCl to form zinc chloride and hydrogen gas, then how to know when you are writing in the form of an equation, how you are going to represent, or how you are going to say that a particular substances which you have taken has undergone a chemical change, and once they have undergone a chemical change, what are the new products formed? So always the new substances whichever so formed in a reaction after undergoing a chemical change are said to be products, and those products whichever are so formed are shown by an arrow placed between them. So the same example, if you take calcium oxide and water, or suppose when I take zinc and HCl, zinc and HCl, when zinc and HCl are reacting, they are forming a new substance. So to show the new substance, what I am using here to represent a new substance form, I am representing with an arrow here. Yes. So once representation is given, so these were the new substances so formed in a chemical reaction are called as products. Are called as products. Yes. Then the reactants are written on left hand side of the arrow. So this is very, very important. Always reactants are written on left hand side of the product. So you can see here zinc and hydrochloric acid, both are reacting, both are undergoing a chemical change. Yes. So, both zinc and hydrochloric acid are reacting together, to form zinc chloride. Yes. So, in such case also you need to give us the what you say, like a confirmation that which are the reactants and which are the products. So, what are the reactants here? Zinc and hydrochloric acid are reacting and they are written on the left hand side. You can see these are written on the left hand side, which we say LHS in the short form. So, always the reactants which are undergoing a chemical change to form a new products are written on left hand side of the equation, and the new substances which are called products are written on right side. So, you can see what are the products obtained here, what are the products formed here, zinc chloride and hydrogen. So, zinc chloride and hydrogen are formed when zinc chloride and hydrochloric acid reacted together and gives you products, and these products are written on right hand side of the equation, written on the right hand side of the equation. Then there is one more what you say, the rule which we need to follow. What is that? If there is more than one reactant, if there is more than one reactant or product involved in the reaction, they are indicated with a plus sign. So, in the beginning itself, when we started representing the chemical equations, I said you that the reactants which are undergoing, if there is more than one element or atom or the substance which is undergoing a chemical change, we represent with a plus sign. Now, you can see here there were two reactants, one is zinc and one is hydrochloric acid. So, if I do not use plus sign here, then will you able to identify how many of the reactants are undergoing a chemical change? No. So, until and unless if you are not using a plus sign to differentiate how many reactants are undergoing, it can be more than one. If there is only a one reactant, then no need to show a plus sign. If in a particular equation, when the reactants are present, then there are more than one. In such cases, those reactants are need to be represented with a plus sign. Means plus sign indicates that in a particular reaction, wherein there are more than one reactants reacting or undergoing a chemical change in a chemical reaction to give you a chemical equation. So, the plus sign plays an important role wherein the two reactants or the two products also so formed are also differentiated. So, here sign between them writing a chemical equation. So, here a chemical equation is represented by in the form of reactants and products. So, I think you are very much clear with the representing a chemical equation. So, what is a chemical equation here? A chemical equation is a representation of reactants and products in a chemical reaction, or you can also say it as a schematic representation of reactants and products undergoing a chemical change and to form a new substance called products. So, how the reactants are need to be written? The reactants are always represented on left hand side. So, these are the two reactants here. So, these two reactants are undergoing a chemical change, and these two reactants are said to be as, and they are written on LHS side, on left hand side of the reaction, and these sort of reactants undergoing a change to form products. So, what are the products formed here? Zinc chloride, it is formed zinc chloride and hydrogen. So, whatever the new substances formed on right hand side of the arrow are nothing but which is on the RHS side of the arrow are said to be as products. Then the last important note which we discussed is, if there are more than one reactant undergoing a chemical change, those reactants are represented by a plus sign. So you can see zinc is a reactant here, hydrochloric is also a reactant. Now both hydrochloric acid and zinc are reacting together, undergoing a chemical change. So the two reactants are represented with a plus sign. And once they have undergone a change, what we have used here? We have used an arrow. So arrow is giving us indication that yes, there is a new product formed when these two have reacted, and the new product is always written on right hand side called as products. And even if in products also, if the new substances obtained are more than one, even those are also represented with a plus sign. So you can see here, even here also two new substances are formed. Zinc chloride is one substance formed, and even hydrogen is also one more substance formed. So how we are indicating it? By using a plus sign. Same way, suppose if I take one more example, if I have used, suppose I took hydrogen and oxygen. Hydrogen and oxygen. Now hydrogen and oxygen are also the two reactants undergoing a chemical change, means wherein hydrogen and oxygen are reacting. So if there is only a hydrogen reacting, then definitely what I will do, I am going to use only the hydrogen. But along with hydrogen, even there is one more reactant reacting with it, and that particular reactant is again been differentiated with a plus sign. So plus sign is gives the indication that there are more than one reactant present in a chemical reaction undergoing a change to give you the products. So how we will estimate a product now? By an arrow. So arrow is giving us the confirmation that there is a chemical change has taken place and a new product is formed. And what is the new product formed here? A water molecule. What is the new product formed here? A water molecule. Now you can see here a water molecule is only a one new substance formed here. If on the product side also, if you have more than one new substance formed, then what you are going to do? Yes, here also you are going to use the plus sign and write the remaining new substances formed on the product side. But in this case, it is only, as it is only a water molecule formed, so that is the reason you will write only and you show it as only with a single representation. But in this case, you can see there were two new substances formed and you are able to show it with a plus sign. So there are different types of the chemical changes whichever takes place, those need to be represented with different forms as per the rules which we need to follow here. Yes. So here you might be questioning or you may get doubt like why what I am been using the number 2 here, like why we need to use the 2, because already you know the formula of the symbolic way of representing, or the formula of hydrogen is to be written as H2 and oxygen is to be written as O2. Then once when hydrogen and oxygen are reacting together, when it's giving you a when that new substance is formed, and that particular new substance whichever so formed, why it's been with 2. So these we are going to discuss in our next class, where we are going to show the particular representation of a chemical equation. So first what we have done, the various sort of chemical changes taking place in the nature and surroundings, we have identified them to be as chemical reactions. So whenever if a chemical reaction taken place, we need to confirm with their color change, either it can be a gas formed, or it can be a precipitate formed, it can be an exothermic reaction, it can be an endothermic reaction, and different new original substances losing their properties. And once these chemical reactions whichever has undergone the change form new products need to be represented. So we can't go with the prolonged form of sentences of those reactions. So those prolonged form of reactions need to be framed into a shorter form. So in a form of a word equation. So the overall the law of prolonged form of sentences of the reactions taking place are represented in a form of a word equation, and that word equation we are saying it to be a chemical equation. Then a chemical equation is a schematic representation of reactants and products undergone a chemical change to form original new substances called products. And here once the what you say like reactants and products are formed, then overall we say it is a chemical reaction completes. Then to frame a chemical reaction in the form of an equation, we are representing the reactants on left hand side of the equation and products on right hand side of the equation. If there are more than one reactant participating in a chemical reaction to undergo a chemical change, we represent with a plus sign. And once they undergo a chemical change and original substance so formed called product are represented by an arrow. If again in the new products, if there is more than one product formed, then we represent with a plus sign. So these are the schematic steps which we need to follow to represent the reactants and products in a chemical equation. So in our next class, we are going to go with a discussion why we need to you can see here like the numbers which I wrote like 2 and or here 2 or it's a 1 or 2 means those are called as actually coefficients. So why these coefficients need to be written or what is the need of them? So here why there is a need to write these numbers in a chemical equation. So already in your earlier classes you know about law of conservation of mass. So in order to promote law of conservation of mass, we need to balance a chemical equation. We say it as a balancing of chemical equation. So here also we need to balance the chemical equation. So in our next class we go with a discussion where we take the different examples of a chemical equations and we try to balance the chemical equation in order to promote law of conservation of mass. So in today's class we have discussed about the different types of chemical changes, and those chemical changes are referred to be as the chemical reactions, and the prolonged form of the long form of sentences of chemical reactions are written in a shorter form of a word equation, and wherein we are writing the long prolonged form of chemical equations which are in a long sentence form in a shorter form of a word equation called as chemical equations. And the chemical equations contains reactants and products which has undergone a chemical reaction. Now in overallly then we have seen how we represent a chemical reaction in a form of a chemical equation, and we have even gone through the rules which we need to follow to write a chemical equation. Then in our next class we are going to discuss like why we need to balance the the numbers whichever we write which are said to be as the coefficients and try to get a balanced form of chemical equation. Yes, I hope so you have understood the today's session wherein we discussed and we have introduced the chapter chemical equations, and in our next class we are going to learn how to balance the chemical equations. Till then just go through the content whatever we have revised. I hope so you have understood it. Keep going on, stay safe, stay healthy. Thank you.